This week, we're going to take a journey into the fascinating world of geometry. What really is geometry? Why not start with trying to understand the meaning of the word? Geometry was the name given by the ancient Greeks for this particular area of math. Alright, let's dust off our ancient Greek dictionaries and figure out what it means. Geo refers to the earth, and metri means measurements. So that gives us a hint about why the Greeks thought this was a very important area of research. Clearly, it's not because they wanted to come up with random shapes in their heads and see if they could figure out some basic properties of these made-up shapes. The Greeks knew that geometry has many practical applications in understanding the world around them. They had big plans for geometry. They wanted to use it to measure the earth and all the objects they saw in nature, both on Earth and in astronomy. Now that sounds like a pretty important area of math. One of the most influential mathematicians ever was the Greek mathematician Euclid, who lived about 2,300 years ago. He was the first mathematician to study geometry in great detail and come up with a set of rules to describe the properties of geometrical shapes we see in real life. He started with 5 very simple axioms, or facts, and then proved almost all other geometric results from these axioms. Euclid, unsurprisingly, is known as the father of geometry. His work on geometry was so comprehensive and accurate that almost none of his theories were disproved for about 2,000 years. Today we know of the existence of other types of geometries that don't satisfy all of Euclid's theorems. In fact, Albert Einstein's general theory of relativity even says that Euclid's theories aren't really true, but they're a great approximation for reality. But that's really complicated stuff. Those of you who become mathematicians and physicists will study these theories when you're much older. For now, just remember, all the geometry you will study in school follows directly from Euclid's work 2,300 years ago. Let's get started. We're going to start with a really simple shape and then work our way up. Let's start with a shape so simple that it's not even a shape. Take a piece of paper. Now, draw the simplest geometric figure you can think of. All right, let's see what you've got. Most of you probably drew a straight line. Some of you probably drew squares or circles or whatever. I'm going to start with something much simpler than all these. This is what I drew on my paper. This is the basic building block of geometry. A point. A point is just a location. In geometry, we mark it with a dot. It has no length, no breadth, no height, just a location. Now, I'm sure all of you have watched movies. You usually sit in front of a TV or a screen and the movie plays out on the screen. Objects in the movie move left and right, but never leave the screen and pop out at you. That's because the screen only has 2 dimensions, length and breadth. It has no depth. Some of you, I'm sure, have seen movies that are called 3-dimensional movies. In these movies, you wear those funny-looking glasses, and then the objects seem to have depth as well. Why am I talking about movies now? Well, I just want you to relate to the concept of dimensions. In general, in the real world, objects have 3 dimensions: length, breadth, and height. Well, how many dimensions does a point have? If it has no length, breadth, or height, you probably guessed it by now. It's an object with 0 dimensions. How much can you say about something that has 0 dimensions? Well, turns out, not very much. So let's move on to more complicated geometric shapes. Let's mark 2 points on a sheet of paper. Let's call these points A and B. Let's say point A is where you are, and point B is where the ice cream shop is. Now, if your parents tell you to go buy yourself your favorite flavor of ice cream, you're going to run straight to the shop, right? You're not going to be distracted by anything else. You start at point A and move in the direction of point B. You'll never change your direction all through. Why? Well, because ice cream's a pretty powerful motivator to keep you focused. So you made it to the ice cream shop by traveling the shortest possible distance. Let's just keep this path you took in mind, and we'll look at this later. Now that you've got your ice cream, it's time to walk back home. So you start walking home. Of course, you're focused on getting back home, but just a little bit less than you were on your way to the ice cream shop. On your way, you decide to stop off at your friend's place to have a chat. Now your friend tells you that there's a soccer game going on nearby, so you decide to go join in for a while. Finally, you realize that your parents would be waiting for you back home, so you head back home. Let's hope your parents aren't too angry that you took so long. Let's now look at the paths you took. On your way to the ice cream shop, you started out in the direction of the shop and never changed direction till you hit the shop. The path you took is called a line segment. In other words, when you start at one point and move to another point, and always stay focused on the second point, and always travel in the direction of the second point, you travel along a line segment between the 2 points. Let's now look at the path you took on your way back. Clearly, you weren't always traveling in the direction of your home. So then, some of the distance you traveled could have been avoided if you had stayed focused on getting home. So, this path you took is longer than the line segment you traveled along on your way to the shop. Now, it doesn't matter what the exact path you took was. We can place your friend's home and the soccer field anywhere, and you'll still travel at least as much as you did along the line segment. Put differently, a line segment joining 2 points is the shortest possible path between 2 points. As we can see, any line segment has only a length. It has no breadth and no height. So, a line segment is a one-dimensional shape. That's it for today. We'll build on these simple concepts we introduced today in the lessons ahead. Have a great day.